Funding for this program is provided by Annenberg Media.
For thousands of years, our capacity to alter the environment has gradually increased. During the last century, we've reached the point where our actions affect the entire planet. Demographer Martha Farnsworth Ritchie examines population dynamics in communities all around the United States, a nation that has a disproportionately large impact on the ecosystem.
Population growth is heading towards some kind of stability as people replace themselves, but where it's located and how they consume, that's the issue for sustainability.
Demographer Deborah Balk combines demographic and spatial data to examine how vulnerable populations in the coastal regions of developing nations will be affected by climate change.
Prior work has predominantly looked at the causes of climate change. This study asks, what will some of the consequences of climate change be? And what will those consequences be for human population and for human settlements?
Predicting future population trends will help policymakers plan mitigation strategies to ensure a better quality of life for coming generations and to protect our environment. Martha Farnsworth Ritchie is the former director of the U.S. Census Bureau, who was instrumental in designing the 2000 census.
Demography is really the science of studying people or studying populations. In the strictest sense, it refers to studying the growth or the decline of populations in terms of obviously people being born, people dying, and then people moving in or moving away. People are the focus of policies, they're the focus of programs, they're the focus of advertising, entertainment, what have you, but they're the common denominator. We don't have an ideology. We count and we place and we describe.
In the United States, the population is measured by the U.S. Census. Every 10 years, the census counts the number of people living in every household across the nation. The Census Bureau also conducts additional surveys on such topics as economics, housing, and health. Demographers use data compiled through the census and additional surveys to study population dynamics. A question that people have about the census is, why should we care?
What we found that people cared about was what demographers do with the data. Probably the thing they care about most is disaster relief. When there is a big natural disaster like the earthquake in California back in the 1990s, I think it was, or the hurricanes in Florida, the relief agencies go straight to the Census Bureau. The Census Bureau right away provides data of how many people per block, how many housing units, what their addresses are, here are the maps, here's how many people you should expect to find. People also like the use of the census for figuring out where schools should be, whether we need junior highs or high schools. They like it very much for hospital planning, healthcare planning, and they also are aware that the government uses the data from the census for traffic planning. What streets are one way during rush hour to help you get home faster? That's the sort of thing people really appreciate.
Another valuable use for census data is its application to environmental science.
The census is a unique tool. It's the only kind of survey or data collection enterprise that we or any country has that tells you how many people are where, and the how many and the where are equally important. Many environmentalists think that population growth is part of the sustainability issue for the United States. That's a debatable assumption. It really comes back not to how many people, but to how they live and to how they use resources. One social scientist has calculated that everybody in the world, all 6.5 billion people, could live and be sustained in the state of Texas. That's one extreme. I don't think I'd like to live in the state of Texas with 6.5 billion people. So it really comes down to how you define sustainability. It's a matter of trade-offs.
A question that scientists ask is, how can an increasing population live in a way that minimally impacts the environment?
For individual places, the question of how many and where really drives the sustainability issue. Quite naturally, as our population has grown, it's put people living and working in areas that might not have been considered salubrious or even viable 50 or 100 years ago. That's particularly true in the Sun Belt, the part of the country that's the southern half, because that's where we've been moving heavily since air conditioning came into being starting after 1950. We see that in low-lying areas, and New Orleans is a great example, we have people living in places that are inundated by floods, by tornadoes. Same thing in Florida. Coast of Texas, we've seen all that. In the semi-arid or arid Southwest, we have people using water at unsustainable rates. Why do we have people in Nevada running sprinklers to grow New England-style gardens? That's a choice that's been made. But now we're coming up against natural limits.
The arid Southwest is not the only area in the United States faced with water supplies reaching their natural limits. Cape Cod, in the Northeast, a region with relatively high precipitation, is experiencing its own sustainability issues. Cape Cod is a location containing ecosystems unique to the New England region. With beautiful sandy beaches and a rich variety of natural habitats, including grasslands, wetlands, and woodlands, Cape Cod is one of the most attractive recreational areas in the nation for both tourists and permanent residents.
I think in general, the Cape community is very aware that we live in a sensitive area. People come here because of its natural beauty and because of what it has to offer, and we need to take care of this environment.
In recent years, Cape Cod has witnessed a large increase in its population.
From 1950 to current, the population has gone from about 50,000, 45,000 across Cape Cod to about 230,000 today. So it's been one of the fastest growing areas in Massachusetts. This is census data here showing the increase in population. More recently, in the red colors are the areas that are growing fastest.
Brian Dudley is an environmental engineer. His fieldwork contributes to the understanding of water quality degradation across the Cape.
As the population on the Cape has increased, we have seen, obviously, a proliferation of development. There has been an increase in the amount of wastewater that is being generated, and as a result, an increase in the amount of nitrogen. And that has had a detrimental impact on a lot of resources, not the least of which are the embayments and estuaries on the Cape. And part of the impact has been loss of eelgrass beds, which in turn means that we have loss of shellfish habitat, finfish habitat.
Inadequate treatment of human waste contributes to the increase in nitrogen levels.
What we're running into right now is that we are seeing the impact of the population increase and the limits of the available wastewater treatment technology that we've got. We get rid of our wastewater in the same system that we take our drinking water from. We're seeing water quality impacts in almost all of our surface waters, and that means both our salty estuaries and our freshwater ponds. majority of those are falling into the category of being impaired. So we have to balance how many people we have, and we also have to balance the technology that we use to treat the wastewater that we put back into the system.
Eric Davidson investigates the levels of nitrogen from vehicle emissions, the significance of which is only now being studied. He arranges air samplers at different distances from roadways to trap nitrogen. The filters are then taken for analysis.
This is total nitrogen from...
We've learned through our research that the samplers nearest the road collect about 5 times as much nitrogen as the samplers nearest to me further away from the road. This is about 150 yards from the road.
Before the study at the Woods Hole Research Center, there was little understanding of the amount of nitrogen pollution coming from traffic.
Because there's a limited amount of land area on Cape Cod, the number of new roads is not very large, so the roads are used more intensively. And roads that were designed for maybe 10,000 cars per day now have 20 and 25,000 cars per day. There's really no place to build additional roads.
Business as usual is not really an option. Our economy is based upon having tourists wanting to come here and spend time here. They're not going to come here if the estuaries are full of algae that smell rotten. So it's extremely important, and we're getting to a tipping point where we have to do something. And I think the same is true across the globe.
We know that people are still going to want to come to the Cape and that growth is going to continue. So what we're really interested in trying to do is appropriately manage that growth. We believe that we can still save the habitat and that it isn't beyond a point of no return, and that's what we're actively trying to do.
By combining census data with physical data collected in field studies, scientists can increase the accuracy of their models and help planners and policymakers prepare for future growth.
What I do essentially is give people the base to look into the future, because we make connections between people and all these things that have costs. We will count how many people are driving SUVs and how far they're driving versus how many people are taking public transport. And then environmentalists or the right sort of discipline can put that together with the figures on fuel consumption usage and really come up and see where is the push point.
One possible solution to the environmental impact of Cape Cod's increasing population is a smart growth approach. Smart growth is a practice used in urban areas to avoid urban sprawl and to plan for long-term environmental sustainability. It aims to concentrate population growth in the inner city, leaving open areas relatively untouched.
We use a computer model that looks at road coverage over 2 or 3 points in time and land cover change over 2 or 3 points in time. And then we can project out into the future the likelihood of change in those areas as well, too, using different types of approaches, whether it's a smart growth approach, which minimizes the amount of land cleared, or whether it's a no-holds-barred or business-as-usual type approach, which is uncontrolled development, basically.
Census data collected across the Cape is an important tool, used to predict the effect of a smart growth approach versus that of business as usual.
We have very good census data at the town level throughout all of Massachusetts, of course, about where growth has occurred. And we are confident we know where it's going to occur because it's going to occur close to transportation corridors. And these corridors can be developed in a smart growth technique, clustering developments, or that you can use sprawl, which is the way it has been done in the past. Sprawl, of course, is very land consumptive. You can accommodate most of the population growth that's projected to occur by looking at some of the areas that are already developed and redeveloping some of these, using the whole idea of smart growth.
Certainly in my lifetime, the U.S. population has tripled. People think that it's because of immigration. Immigration accounts for maybe half of our annual population growth. Other people think it's births because we have a higher fertility rate than other industrial countries, but we're actually just replacing ourselves through birth. Probably the primary driver of our population growth is that we aren't dying as young as we used to. That 300 millionth person that the newspapers were trying to trace down, thinking that it was a baby born, it wasn't a baby born. It was someone who died on Wednesday instead of Tuesday. That was our 300 millionth person. And that's a major source of our population growth. One demographer, Joel Cohen from Rockefeller University, a few years ago, looked at all the estimates made of population size and sustainability, trying to answer the question, how many are too many? And it really came down to a huge array of estimates, and it depended on what kind of life you wanted. And that's what really goes into this equation. It's a matter of trade-offs.
While Farnsworth Ritchie's research is based mainly in the United States, Deborah Balk's studies have a predominantly global perspective. With 6.5 billion people currently living on the planet, it's estimated that world population may peak at around 9.1 billion in the next 50 years. Scientists predict that climate change, linked to greenhouse gas emissions, will lead to changes in the global environment, including a rise in ocean levels. In developing nations, the majority of population growth is projected to take place in cities. Many of these cities are situated in low-lying coastal areas most at risk for climate change effects.
We know that climate change will lead to sea level rise, and that, of course, will affect coastal dwellers more than others. But we also know that it will increase storm surges and flooding, coastal in nature. In fact, we found that coastal ecosystems were disproportionately urban and disproportionately dense in both urban and rural areas. And therefore, we became particularly interested in trying to estimate the population and the urban population that would be at greater risk of the consequences of climate change.
Deborah Balk incorporates spatial data and methods to assess population characteristics and behaviors.
There's a disproportionate contribution of the causes of climate change coming from one set of countries, mostly the West, and a disproportionate set of consequences or burden on countries that are predominantly poor. And it turns out that some of those countries are also the ones that will be experiencing the most rapid urbanization in the future. And much of that urbanization is going to occur probably in these coastal zones and low elevation coastal zones at that.
Before Deborah Balk and her team began their study, there was no accurate estimate of how many people live in coastal areas within a 10-meter elevation above sea level. While no one expects ocean levels to rise 10 meters, it's within this zone that climate change will have the most effect, in terms of flooding and storm surges from more frequent and more energetic coastal storms.
The fact is that in Asia you have many situations where you have large urban areas in very vulnerable positions, and between both of those you have the potential for a lot of damage. And if you take a city like Dhaka that is located right on the coast and has a huge informal settlement population with people that already don't have good access to sanitation and water systems, don't have good sewage systems. So when the city flooded in 2005, there were massive deaths. When you think about floods becoming more frequent, it's a real problem.
Balk's team started their studies by collecting census data created in countries across the world. On this map of the Dominican Republic, irregular red lines surround subnational administrative units for which census data is available. One problem for Balk's team is how to reconcile these data with precise grid format satellite data, shown here in blue. To obtain boundaries of urban areas, a third source of information was used: nighttime images of the Earth from space.
NOAA produces a nighttime lights data set that was measured in 1994 and 1905. and it's a globally consistent data set. That means they use the same measures everywhere. It measures brightness of places. We combine the lights data with the population data, as well as a few other data sets to make sure that we can confirm each light is actually a population place.
Using a combination of various population and geographic data sets, Balk is able to determine how many people live in low-elevation coastal zones.
This is southern Vietnam, so we see the white areas are administrative boundaries. The red areas indicate the nighttime lights, the urban areas, and this blue data set is the elevation zone that we've constructed from the SRTM data, Shuttle Radar Topography Mission Elevation Data Set. So we have Ho Chi Minh City here, that's the big red area, and we'll now add the elevation buffer. The areas that remain bright red are above 10 meters, and all other areas right here where the blue has overtaken it is below 10 meters. And it's evident that the entire city is not below 10 meters, but much of it is. This notion of combining these different types of data at these fine resolution is an innovation. And it's an important one for affecting policy, because without data of this type, you can't come up with estimates that are accurate.
As part of the worldwide effort, projections for ocean level rise have been made for the New York metropolitan area, home to approximately 20 million people.
As I was doing this research, since we're in New York, many people have said, well, is my home going to be flooded in the next 100 years? Is this community going to be gone, and so forth? And therefore, I became interested in coming up with estimates for New York City.
All 5 boroughs of New York contain dense populations within the low-elevation coastal zone.
This is the distribution of population. The darker the color, the more dense the population. So this is at 5 meters, now 7 meters, and now 10 meters.
In New York, storm surges reach 3 meters above sea level about once a century. These 100-year storms cause severe flooding and damage in coastal areas, endangering essential infrastructure such as power stations and water treatment facilities. Models predict that climate change may reduce the average interval between these so-called 100-year storms to once every 19 years by mid-century, and possibly as often as every 4 years by 2080. One New Yorker raising awareness of the potential impact of climate change is artist Eve Mosher.
All right, let's go for a walk. I'm working on a public art project called the High Water Line Project. And for the project, I'm drawing the 10 foot above sea level line around the entire coast of Brooklyn and lower Manhattan. So it's almost 70 miles that I'm covering. And the point of the project is to get out into the communities that are going to be affected by that and give them a visual idea of what that means, what the 10 foot above sea level line means, and also give them the tools to do something about that. So along my way, I'm handing out action packets that give people tips on how to live more sustainably. It's a really important part of my project is the whole human element. I think a lot of times they don't know, okay, climate change. First of all, what does that mean? And then what do I do about it? So you have the media scaring you into thinking climate change, we just can't do anything about it, we should all panic and run away, run to higher ground. But there are things that we can do about it, and so it's nice to be able to get out and talk to people. And I've found that no matter what background, no matter where people come from, they're all really interested in talking about it because they do understand that it is a future that could happen in our neighborhoods or in the neighborhoods that I'm in.
This area most likely is like where the flood would appear.
Yeah, it would come in this way. The Paddogat would overflow, you know, the basin over there.
Yeah.
You would get flooded in this area here.
It happened in Coney Island a couple years ago.
Yeah, Coney Island's extremely susceptible to flooding. And that's going to be a big deal because the whole coastline of New York City is going to change.
Thank you for your advice. And
thanks
have a
for stopping.
successful
Yeah, I hope you feel better. Thank you very much.
Okay.
One of the things that I did also discover when I was mapping out the line is that there are a lot of public housing along the coast, and currently you have a lot of poor people living in the coastal communities, so they're the ones who are really going to be affected by this, which is similar to things in the rest of the world, where Bangladesh is a very poor country that's very susceptible to climate change and flooding.
With many of the world's poor and disadvantaged living in endangered coastal zones, planning for the future is becoming critical.
New York City is one example where the mayor is starting to think about climate change, both in terms of cutting greenhouse gases and making the city more livable, but also coping with some of the dangers of climate change. The issue is that it's not just New York City that needs to be taking this on. It's really all cities, both large and small. And so there's a lot of planning work and learning that needs to be done. And I think it's important for global leaders to start taking the lead on this issue and understanding that people are at risk even if they're living in the developed world. But particularly in the developing world where resources are less, where the poor are more vulnerable and dependent on faulty infrastructures to begin with, where the potential for really catastrophic situations to occur are very likely.
Deborah Balk's study has determined that more than 600 million people worldwide live within the 10-meter low-elevation coastal zone, with more than half concentrated in highly populated urban areas.
One of the things that we learned in this study was that the low-elevation coastal zone in some areas, Bangladesh and China being two examples, is urbanizing at a much faster rate than we see elsewhere in those countries. Those estimates are going to be fundamentally important to policymakers and to future studies that will allow us to consider future rates of urbanization, who's going to live where. Hopefully in the future we can also ask more about the characteristics of people living where in these various places. And I think this pioneering approach that we've adopted offers a lot of promise for coming up with much more rigorous estimates and descriptions of current population, future population, current environmental conditions, and future environmental conditions.
Funding for this program is provided by Annenberg Media. For information about this and other Annenberg Media programs, call 1-800-LEARNER and visit us at www.learner.org.